Hi, ladies and gentlemen. We are looking at notes 2.1, which are on adding and subtracting polynomials. So I'm not giving you a separate note sheet for this note, so take notes on your own paper and make sure you title it Notes 2.1, Adding and Subtracting Polynomials. Okay, so the first question that we have here is to determine the simplest equivalent polynomial. So take a moment to write it down and then come back to me and we will take up how to do this question. So in order to be able to add any terms at all, they need to be like terms. And in order for terms to be like terms, they have to have the same exponent, they have to have the same variable first, and then they also have to have the same exponent. Okay? So, for example, 3x squared is like x squared right here because they have the same variable and they have the same exponent, okay? So if I have 3x squared and 1x squared, when I put them together, I get 4x squared. And then I also have, and I like to cross them off when I'm done so I don't get them mixed up with each other, negative 6x and positive 4x. And when I add negative 6 and positive 4 together, I get negative 2. So I get negative 2x. And then I've got 5 will combine with negative 7. Because they don't have any variables at all, they're constants, they're like terms, and 5 minus 7 is negative 2. Then I need to make sure my answer is in descending order, and then I'm all set to go for this question. That's my answer. Now, if you notice in this problem right here, the only thing that I had was two sets of brackets, two expressions in brackets, and a plus sign. So I could technically distribute this plus sign right here, but when I distribute this plus sign through, it doesn't really change anything. So that's why I didn't go ahead and change anything here. So let's take a look at our next example. So again, take a moment to write down this example. And this time we do have a negative that needs to be distributed through. And that's going to get distributed to everybody inside of your brackets right here. Okay, so the 5d to the power of 3 stays the same because there's nothing distributed in front. It has technically has an invisible plus sign in front. Minus 7d stays the same, plus 1. And then minus, when I distribute the negative to the positive 2d cubed, I get negative 2d cubed. This negative distributed becomes negative 3d squared. This negative will make the negative 9d positive 9d, and this negative here will make this positive 11, negative 11. Then I can start to put things together. So 5d cubed is like negative 2d cubed, and when I put those together, I get 3d cubed. Okay, then I'm going to go to my next highest exponent, which is d to the power of 2. So I'm going to write down minus 3d squared because there's nothing else that's like it that I can combine it with. Okay, next I have negative 7d can be put together with positive 9d, and negative 7 plus 9 is 2, so I get plus 2d, and I can cancel those two out. Lastly, I have my constants, so I can put together 1 and negative 11, and I get negative 10. My answer is in descending order, and there are no other terms that are like each other, so this is my final answer, and I'm done with this example. All right, we're going to do one more example. Determine the simplest equivalent polynomial again. Take a moment to write down the example. All right, so here I have to distribute twice. I'm going to distribute the 2 through to all of these terms right here. So 2 times 4x squared gives me 8x squared. 2 times 14x gives me 28x. And 2 times 13 gives me 26. Okay, then I'm also going to distribute this negative 3 through. So when I multiply negative 3 by negative 3x squared, I get positive 9x squared. When I multiply negative 3 by 12x, I get negative 36x. And when I multiply negative 3 by 21, I get negative 63. Okay, lastly, all I have to do is put together any of the terms that are like each other, and then I will be done with this problem. So 8x squared is like 9x squared because they have the same variable and the same exponent. So when I put them together, I end up getting 17x squared. Okay, 28x is like negative 36x, and when I put those guys together, I get negative 8 x. Okay, 26 is like negative 63, and when I put those together, I end up getting negative 37. In my answer here, it's in descending order, and there are no like terms, so I am done with this problem. Okay? All right, our last example that we're going to look at is how to determine equivalency in polynomials. So this question has a lot of words, so please take a minute to just go ahead and copy down what's written here, pause the video, and then come back to me when you're ready to move on. Okay, Derek enjoys working with model rockets. He wants to determine the difference in altitude of two different rockets when their fuel burns out and they begin to coast. The altitude in meters are given by the following equations. A sub 1 of t is equal to negative 5t squared plus 40t plus 400, and a sub 2 of t is equal to negative 5t squared plus 45t plus 350. The function f of t represents the difference, so that's key, the difference in the two altitudes. So f of t is equal to a sub 1 of t minus a sub 2 of t. When Derek simplified f of t, he got another function, g of t is equal to 85t plus 750. And we want to know if he is correct or not. Okay, so we're going to do method 1. We're going to solve this using several different methods. Right now we're going to look at method 1. Method 1 is just to simplify f of t. Okay, so we know that f of t is equal to a sub 1 of t minus a sub 2 of t. Okay, so I'm literally going to take a sub 1 of t, which is this expression right here, and I'm going to say it's equal to negative 5t squared plus 40t plus 400. Okay, and then I'm going to subtract a sub 2 of t, which is this expression right here, or that function right there, I should say rather. So minus negative 5t squared plus 45t plus 350. Now, remember, if we have a minus sign here, we need to distribute that minus, that negative, to everybody. So here, this stays negative 5t squared plus 40t plus 400, but this negative 5t squared becomes positive 5t squared, positive 45t becomes negative 45t, and then positive 350 becomes negative 350. Okay, now I can go ahead and start to put things together. So negative 5t squared is like 5t squared, but they cancel each other out, so I don't have it anymore. Now 40t is like negative 45t, so I end up getting negative 5t. Okay, and then 400 is like negative 350. When I put those together, I get 50. So that means that f of t is equal to negative 5t plus 50. So I can say, therefore, f of t is not equivalent to g of t, because we have g of t is equal to 85t plus 750, making Derek's answer incorrect. Okay. Now, one thing I want you to think about is if Derek got g of t equals 75t plus 85t, sorry, plus 750, he didn't get just a random answer. I want you to think, where do you think his mistake was? And we're going to discuss this next time I see you in class. So what do you think his mistake was that he made? Think about that, write yourselves a note, and we'll talk about it next time I see you guys in class. Okay. All right. So method 2 is to look at it algebraically, or sorry, graphically. So we're going to look at graphical representations. Okay. And if f of t and g of t were equivalent expressions, then they would be the exact same graphs. So let's go ahead and graph out a sub 1 of t, a sub 2 of t, f of t, and g of t. So we know that a sub 1 of t is equal to negative 5t squared plus 40t plus 400. Okay, so this is what a sub 1 of t is going to look like. We also know that a sub 2 of t is equal to negative 5t squared plus 45t plus 350, I believe, right? So we know our two a sub 1 and a sub 2 functions. Now we also know that f of t is equal to a sub 1 of t minus a sub 2 of t. So when I take a look at my graph right here, this blue graph is a sub 1 of t minus a sub 2 of t. And then we also know that g of t is equal to 85t plus 750. So when I look at my graph, are the blue graph and the green graph going to be exactly the same? No, they're not. So that means that my f of t function is not equivalent to g of t because they are not the same graph, okay? So we can say Derek is incorrect because f of t is not the same graph as g of t. Okay? And then let's go ahead and graph out what we got for f of t when we simplified it. So we ended up getting negative 5t plus 50. So let's go ahead and graph that out and see if we end up getting it to overlap with our blue graph right here. So we'll just call this k of t is equal to negative 5t plus 50. And if you look right here, the graph, the orange graph coincides with our blue graph. They're the exact same graph, so those are equivalent expressions. Okay? All right. Last method that we have is method 3, and that is to look for something called a counterexample. Okay? So what we're going to do is we are going to evaluate f of t and g of t at a specific value. So we know that f of t is equal to a sub 1 of t minus a sub 2 of t, just like we did before. So we're going to say that f of t is equal to negative 5t squared plus 40t plus 400 minus negative 5t squared plus 45t plus 350. Okay, so now I'm going to actually plug in a random value and see what I end up getting as my output. So I'm going to choose the easiest value I can think of, and that's 0. So I'm going to plug it in, and I get negative 5 times 0 squared plus 40 times 0 plus 400 minus negative 5 times 0 squared plus 45 times 0 plus 350. Okay, so right here I end up getting f of 0 is equal to 0. This turns into 0. Another 40 times 0 is another 0 plus 400 minus, this also turns into 0. This is another 0 and then plus 350. So I get f of 0 is equal to, inside of my first set of brackets, I get 400. Inside my second set of brackets, I get 350. So it's 400 minus 350, which is 50. Okay, so now I'm going to figure out what g of 0 is going to be. So I'm going to do 85 times 0 right here plus 750. Well, 85 times 0 is 0. 0 plus 750 is equal to 750. Okay, so therefore I can conclude, again, Derek is incorrect because f of t is not equal or equivalent to g of t for all values of t. And this is why this is called a counterexample. So a counterexample proves a statement is false. Now, here's something that I would like you to think about as well. So there are two things that I want you to think about for the next time I see you in class. And that is it possible for me to use method 3 to prove that two two expressions are equivalent to each other, okay? Or two polynomials are going to be equivalent to each other. So can I use method 3 to prove that a statement is true, essentially, okay? So think about that, and we'll talk about that next time I see you guys in class. All right, have a great day.